So, we need to find the general term for the sequence being summed if the formula for the sum of the first n terms of this sequence is given by the sum of n equals n squared plus 5n plus 6, and hence find the 23rd term of the sequence. So this one here is actually quite tricky compared to some of the things that we've been doing before. If you're pretty confident with the content, please pause the recording and have a go at this yourself before I give you the solution, just because it is a really good exercise. So I will get into the solution now though. So for this one here, what we need to consider firstly is what we want to know. So we want to find the general term. We want to find something with Tn in it, because this is going to give us the general term. Remember, the general term is going to be our Tn plus something n plus our difference, yada, 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 right? Our general term is going to have Tn in it, it's going to have n in it, and it's going to have some constant, which is going to be our difference in it, right? So what we want is we want an equation with Tn in it that we can somehow get from this sum of n. So this is typically like a general approach that you take for a hard question. Just in general, what I find really helps me, if when you read a question you kind of look at it and don't really know where to go with it, is to have a think about, what do I actually want? And then you can kind of work backwards from there. So now we're thinking we want the general term, which is going to have Tn in it. We want some kind of equation with Tn in it from our sum equation, and then, from there we can find the 23rd term. It's pretty simple. It's what we've been doing so far. The tricky part is finding the Tn part. So we want a equation with Tn in it, and we want to somehow derive it from this, not sure what that was, from this Sn formula. So if you haven't already, pause the recording, have a quick think about this, but I'll go through the solution now. So if we want to find if we want to find an equation with Tn in it, we need to think about what our sum formula actually represents, apart from the formula that we've been given. So if you think about it, our Sn formula tells us the sum up to the nth term, right? So T1 plus T2 plus T3 and so on up to the term before n, and then finally our term n. We're just adding up all the terms up to term n, whatever term n is. So this is useful because it puts Tn in our Sn formula. So this kind of provides us with a link, right? But this still quite isn't enough yet. That string of words did not make sense. This isn't quite enough yet. That's what I meant to say. Because we still have all of this in here that we don't want. We only want this Tn part, right? So now we need to think about a way that we can isolate this Tn part. Again, have a pause of the recording, have a think about it, see if you can have a go. But the way that we actually need to do this is we need to think about how to take away all of this stuff beforehand. And what we can do is, if we think about the sum of the terms only up until this point, we're going to have the same thing, term 1 plus term 2 plus term 3, yada yada yada, up until the term n take 1, right? Because we're only finding the sum up to n take 1 terms. And this tells us this part, right? So what we can kind of deduce from here is that our Sn is going to be equal to S of n minus 1 plus Tn. So this is helpful because it gives us a method of incorporating Tn into our Sn equation and then only expressing it in terms of n. So we're going to get into applying this in the next slide. So, as you can see, what we've done here is we have rearranged our formula from before, the blue one that we had in the last slide, to isolate Tn. So from the last slide, we just took this over here. So we got Tn is equal to Sn take Sn take 1. Which makes sense, right? Because if we have our Tn and we're minusing away all this kind of stuff in the middle, we're just going to be left with Tn. So, applying this, we now need to sub in n. So, this section here is Sn. Now we're going to be taking away the sum for n take 1. So instead of having n, we have n take 1, n take 1. And this is really useful because now we have something for Tn in terms of n only. And we know that our general definition of a arithmetic sequence is going to include Tn and n. Those are going to be the two unknowns, or the two variables, I should rather say, in our equation. So, simplifying this, we used our binomial expansion for this term here. So if you don't remember the rule, I'd really recommend learning it, which is if you have a plus b, any terms, to expand it, you're going to have a squared plus 2ab plus b squared. This isn't in your formula sheet, but make sure that you remember that one because it does come in handy. So now that we have simplified all of these in the brackets, we can now move further on and we can actually simplify it even further. So as you can see, these two n squareds are going to cancel out because we have n squared take n squared. The 5n take 3n are common terms, and then we're going to have 6 plus 2. Okay. So this leaves us with Tn equals 2n plus 4, which is our general form. So now we can use this information to find the 23rd term. So we're going to sub our n equals 23, and this is going to give us that our 23rd term is 50. Okay, so that was a pretty tricky question. If you didn't understand anything, please go back and watch it again. But otherwise, we are now going to get into our next topic, which is